Hello dear students, in today's class let us discuss about acid amides. Acid amides are the derivatives of carboxylic acids in which the OH group of the carboxylic acid is replaced by the amine group. So this is the carboxylic acid. The OH group of this carboxylic acid, if it is replaced by the amine group, so then the acid amides are formed. So acid amides are formed when the OH group of the carboxylic acid is replaced by the amine group. So the general formula of the acid amides can be written as RCONH2, where R may be an hydrogen atom or an alkyl group or an aryl group. So let us write some examples for the acid amides. So if R is an hydrogen atom, then the acid amide will be RCONH2. So this is formamide. So the name of this acid amide is formamide. So if R is a methyl group, so then the acid amide will be so this is acetamide. So next one more example. If R is a phenyl group, so this is benzamide. Benzamide. Okay. So let us continue our discussion on acid amides with the chemical properties of acid amides. So when acid amides, they undergo hydrolysis. So that is the hydrolysis of acid amides. So when acid amides undergo hydrolysis, so they will going to form carboxylic acid and ammonia. Carboxylic acid and ammonia. So let us write its reaction. So this is acid ammonia, that is acid amide. So when acid amide undergoes hydrolysis, so we know that it will form carboxylic acid, carboxylic acid and ammonia. So let us write an example. So here R may be an hydrogen atom or an alkyl group, or it may be an aryl group also. So let us write an example. So this is acetamide. So when it is undergoes hydrolysis. So we can expect the carboxylic acid that is acetic acid and ammonia. Okay, so acid amides upon hydrolysis form carboxylic acid and ammonia. So next, let us continue our discussion. One more property of acid amides. So that is a reduction of acid amides. So the acid amides undergo reduction in presence of the reducing agent lithium aluminum hydride to form the primary amines. So the acid amides, so they undergo reduction with the reducing agent lithium aluminum hydride lithium aluminum hydride to form the primary amines. So let us write the general reaction. So acid amide when it is reduced in presence of the reducing agent lithium aluminum hydride, it forms the primary amines. So this is primary amine. So where R may be an hydrogen atom or an alkyl group, or it may be an aryl group also. So for example, so this is acetamide. When acetamide is reduced by using the reducing agent lithium aluminum hydride, it forms that is ethanamine. Okay, so acid amides when subjected to reduction in presence of reducing agent lithium aluminum hydride, so they form primary amides. So next, one more chemical property of acetamides is the Hofmann's degradation or rearrangement reaction. So that one, let us discuss. So in Hofmann's degradation reaction or the rearrangement reaction, so the acid amides are treated with bromine and potassium hydroxide solution. So they form the primary amines. So here the primary amine which is formed contains less number of carbon atoms than the acid amide. So that's why the reaction is called as the degradation reaction. So the number of carbon atoms in the primary amine will be less than the number of carbon atoms in the acid amide. Okay, so that is called as Hofmann's degradation or a rearrangement reaction. So let us write its general reaction. So acid amide when it treated with bromine and potassium hydroxide solution, KOH solution. So the acid amide forms the primary amines. 2H2 where R may be hydrogen or alkyl or aryl group. So example, NH2, so this is acetamide. So when it is treated with bromine and potassium hydroxide solution, so it forms methanamine. This is methylamine or methanamine. Plus 2H2. Okay, so in case of Hofmann's degradation reaction, acid amides treated with bromine and potassium hydroxide solution to form primary amides.